Good day everyone, my name is John Jericho RSF from BIT2K, here to explain to you things you need to know about idle air control valve. But first, what is a idle air control valve? While starting the car, a cold engine will require more air to idle smoothly. Also, when you step on the gas and then let off, the air supply to the engine ceases. But to ensure that the engine doesn't jerk to a halt, a little air has to be supplied to the engine. From the above-mentioned instances, it is clear that the regulating air supply is vital for the smooth running of the engine. At the same time, the amount of air that enters your car's engine should be kept under check, else the engine will have more air than fuel. This is where the idle air control valve enters the picture. The idle air control valve is located on the throttle body of the fuel-injected engines, where it works with the vehicle's ECU to electrically regulate airflow to the engine to ensure smooth idling. So this is the types of idle air control valve. In future slides, you will realize they are practically all just the same features, but they have different types of builds, like this Ford solenoid bypass air valve, which you can see. Uh, it will also in future slide I will also tell where they are connected. And this is a stepper motor, a thermal air valve, and a rotary type valve. Okay. All these types are idle air control valves, just different designs and concepts. Okay. Purpose of a idle air control valve. The idle air control valve is controlled by the engine's control unit. The ECU is the monitoring module or computer of the car that keeps a check on the engine idle speed. The ECU uses the IAC valve to control the amount of air that is allowed to bypass the throttle intake plate so as to keep the engine idle speed constant. There are two idle settings in any vehicle. The minimum idle setting is done at the time of manufacturing itself, which allows a certain amount of air to pass through the valve irrespective of the AIC valve position. The running idle setting is achieved by the combination of the IAC valve position and airflow. If the sensor in the IAC valve detects a drop in the idling engine RPM, it opens up and allows air to pass there by increasing the RPM, thus preventing the engine from stalling and keeping the engine warm and running. At idle, a fixed or phase or throttle plate opening might cause a fuel-injected engine to stall if the power, steering, or air condition load the engine, so a variable idle control was needed. One of the advantages of the IAC valve is called throttle following, which is needed when you floor the car and suddenly close the throttle valve. The IAC valve in such situation temporarily opens up to allow some air to pass so as to compensate the sudden drop in air and allows the engine to decelerate gradually. Okay, so a little bit of information. If you have seen or diagnosed a carbureted engine, usually carbureted engines have butterfly type valve, like in a modern throttle body. Because if you can remember in past lessons, a throttle body only has a flap that opens. That's called a butterfly flap or valve. So in a carburetor, the butterfly flap, while having a physical wire that is connected to the gas pedal, as they call it, there is a thing called idle screw, which is connected there. In a carburetor, you only need to open slightly that butterfly valve so that air can flow through the engine. That's where the era is called engine tune-up, as it's called. But since the air fuel mixture happens in the engine manifold or directly in the engine cylinder instead of the carburetor, there is a slight hindrance on how the idle should be kept, especially that you need a vacuum when in an idle. So this is where the idle air control valve was designed. Okay, next. Construction of a idle air control valve. The IAC valve is fitted in the throttle body with the help of rubber gasket and locking bolt. It have one water inlet and one water outlet inside. This warm water circulates continuously and may keep warm incoming air. The IAC valve has one air inlet and one air outlet. Both are connected with bypass air passes. The IAC valve has a electrical solenoid which is connected with the ECU via electrical wire. Sorry. So this is the simplest type of solenoid idle air control valve that I could see diagram. It's very hard to find one because usually they all use the same type of picture, but this is the simplest form yet. So this is the thing that I was talking about, the butterfly valve or the throttle body in short. So you can see it's connected here in the throttle body. Now in my researches, some of the idle air control valves are directly controlling this. I would show you a video later on, controlling this type of throttle disc. This is the one this is the one that they control immediately, but in future models they've seen that it should be separate. As you can see here, this is the IAC valve. So once the engine needs a boost of power or balance the idling, this would go down and go up. And this is the air from the air filter, and this is for air going to the intake manifold. This is the main body. Okay, electrical solenoid, as they call it. You would see that in the video later on how this thing works. Okay, and this is the different types that you have seen, albeit different designs. That is, some have small actuators that you see only uses a solenoid and the body. Some has a fully dedicated body and some are really compact. There you can see there. It also uses a diaphragm, solenoid. More on their operation in next slides. Okay. Operation of an idle air control valve. The valve is fitted such that it either bypasses the throttle or operates the throttle butterfly valve directly. This is what I was saying earlier on. The actuator consists of a linear servo motor that controls a plunger, which varies airflow through the throttle body. The position of the servo motor and hence the amount of air bypass is controlled digitally by the engine ECU. This allows the engine idle speed to be maintained constant. The linear servo is most commonly a combination of DC motor, lead screw, and a digital optical encoder. There is essentially no difference in efficiency between the techniques of bypassing the throttle butterfly and operating the butterfly itself. The IAC allows the ECU to maintain the minimum RPM respectively of change in the engine load, sometimes referred to as anti-stall feature. Thus, the driver can more easily move the car from standstill by merely releasing the clutch on manual transmission or the brakes with automatic transmission without having to simultaneously press the accelerator. So the thing with called anti-stall is most commonly called it's two-step, where you bleep the throttle body, you bleep the engine so that when you downshift, the transmission and engine won't have a different RPM ranges. So this is a bit complicated to explain, but usually when you change gear, you wait for the RPM to rise, right? So when you downshift, this is the opposite of it, where you intentionally rise the RPM so that it matches the gear ratio of the gear that you are downshifting it, in layman's terms. Okay, so now we're going to watch a video.
This section examines idle speed control devices. The solenoid-type air control valve acts on signals from the control unit to bypass a measured airflow around the throttle plate. The position of the valve depends.
So this you can see this again, the construction of it. This is the solenoid type of air bypass. It's the ECU, which controls the solenoid.
Control unit applies to the solenoid. Maximum current flow opens the valve fully to give maximum airflow.
Okay, current controls the solenoid via the ECU. So this is the air coming from the in coming from the air box, and here is the bypass road where it goes to the intake manifold.
Position for starting. Thereafter, the taper valve is positioned by pulsing the solenoid winding circuit at a predetermined frequency.
So it has a predetermined frequency, as said in the video, where it pulses it.
And therefore the amount of airflow depends on the on time of the pulse. A long on pulse with a short off pulse will produce a high average voltage and therefore a large opening of the valve.
So it builds up the voltage, and when the voltage is released, then the pulse of the valve opening will be longer.
With a long off pulse will produce a low average voltage and a small valve opening. This on and off time is called the duty cycle, and it's generally expressed as a percentage. Variations in pulse width at the set frequency is called pulse width modulation. The stepper motor type of idle control.
So this is the stepper motor type. That's the solenoid type. This is stepper motor type.
Using a screw and nut assembly. The nut is part of a centrally located permanent magnet armature. It engages with the screw on the pintle. Rotating the armature extends or retracts the pintle, which closes or opens the air passage. Rotation occurs by switching current flow in two coils. The pintle turns in forward or reverse steps, numbered from 0 with the bypass air passage fully closed, up to 255 for maximum airflow.
So from 0 to 255, this motor controls the pintle and screw. This one seems a little bit more accurate if you want to control the air um, speed of the idle and so on and so forth. And this one seems more accurate as it can just reach from 0 to 200 something. That's said in the video. And this one goes up and down using the screw.
Such a large number of steps allows the pintle position to be finely controlled. When the idle speed is controlled by the position of the throttle plate,
This one uses the throttle plate as the one similarly like in a carbureted type engine. So this is like the idle screw in a carburetor. But in an EFI, even the idle screw is controlled by a electronic device, controlled by the ECU, which is all right because the ECU is the one that's controlling the air fuel mixture, not the carburetor.
be used as a variable throttle stop. The controlling circuit can let current flow through the motor in either direction to extend or retract the linear actuator. Solenoid valves can also be used to bypass a predetermined amount of air around the throttle plate. These may come into operation for specific load compensation. For instance, when the air conditioning compressor is engaged.
So if you have ridden a car, usually you would notice that after starting the car, you would wait for the idle to come down, right? If not, that's a very bad habit of not waiting for the idle to come down when you start a car. And once you start it and it's in a considerable amount of idle. When you turn on the AC, the idle usually jumps to a 100 to 200 RPM speed. From 800, usually it goes to 900 or 700, so on. That's because it's need more load for operating the AC motor, AC compressor, I mean.
Passageway of fixed dimension and do not vary the opening.
Okay. Thanks for listening. Hope you've learned something.